What's up, everyone? Welcome back. I'm Mick. Today, we're diving into one of the most debated and closely watched pieces of military hardware in the modern era. Imagine taking a massive 120mm main gun, the exact same heavy-hitting caliber you'd find on a 60-ton main battle tank, like the Leopard II or the mighty M1 Abrams, and strapping it onto a wheeled chassis that weighs just over 30 tons. On paper, it sounds like a physics anomaly. Is the result an engineering marvel of the future, or just a fragile glass cannon waiting to be shattered on the modern battlefield? Today, we're doing a deep dive into the Centauro II 8x8, Italy's ultimate wheeled tank destroyer that is completely rewriting the rules of 21st century warfare from the ground up. Before we get into the insane specs of this beast, I want everyone to zoom out and look at the broader strategic trends in modern warfare. If you've been paying attention to global conflicts over the past few years, you've noticed a massive tactical shift away from the armored dinosaurs, the traditional main battle tanks that rely solely on massive size and heavy armor to survive. While incredibly powerful, MBTs come with crippling limitations: extreme weight, horrific fuel consumption, and, worst of all, sluggish strategic mobility. You simply can't drive a 60-ton tracked behemoth across the country at highway speeds without destroying the roads, collapsing rural bridges, and completely wearing out your tracks in a matter of hours. You have to rely on massive flatbed trailers, rail transport, and an endless convoy of vulnerable fuel trucks that just become giant targets for enemy drones. In a modern conflict where speed, agility, and rapid deployment are everything, those logistical bottlenecks are an absolute death sentence. Enter the concept of the wheeled tank destroyer. This is where the Centauro II perfectly executes the hit-and-run doctrine. Modern militaries desperately need units that can deploy rapidly via standard highway infrastructure, strike a high-value target with overwhelming, decisive firepower, and then fall back and displace before enemy artillery or suicide drones can dial in their coordinates. It's all about surviving through speed. But here's the catch. Slapping a massive, high-recoil gun on a relatively lightweight wheeled vehicle is incredibly hard to get right. Just look at the competition. The U.S. Army's M1128 Striker mobile gun system, which only carried a smaller 105mm gun, turned into an absolute logistical nightmare. Its finicky autoloader constantly jammed, and the chassis simply couldn't handle the violent firing recoil, causing internal electronics to literally shake themselves to death, ultimately leading to the system's total retirement. Or look at the French AMX-10RC deployed in Ukraine, which faced heavy battlefield criticism for having armor so thin it couldn't survive basic artillery shrapnel, proving that you can't just sacrifice all your armor for speed. So the million-dollar engineering question: how did the Centauro II actually solve this? How does a 30-ton wheeled vehicle fire a 120mm 45 caliber, sending a kinetic penetrator downrange at Mach 5 without flipping over or tearing its own hull apart? The credit goes entirely to the brilliant engineers at the CIO consortium, Iveco-Oto Melara in Italy. They didn't just bolt a heavy tank turret onto an armored truck. They designed an incredibly advanced recoil mitigation system from the ground up. It starts with a highly specialized pepper pot muzzle brake that vents expanding gases in multiple directions to massively offset the violent rearward recoil. That's seamlessly combined with a heavy-duty hydraulic buffer system at the base of the gun to absorb residual kinetic energy. But most importantly, the chassis was designed with an ultra-low center of gravity. By perfectly distributing the weight across an independent hydro-pneumatic suspension on all 8 wheels, firing that massive 120mm gun barely rocks the vehicle. The suspension eats the shock, it maintains its stability, and the driver is instantly ready to hit the gas and move. It is an absolute masterpiece of physics and automotive engineering. And if we look at its brain, the Centauro II isn't just a big gun on wheels, it's a supercomputer enclosed in armor. Its fire control system easily rivals top-tier modern MBTs, featuring a fully integrated hunter-killer architecture. This means while the gunner is aiming at target number 1 and preparing to fire, the vehicle commander can use an independent 360-degree panoramic sight to scan the horizon, identify the biggest threat, and digitally lock on to target number 2. The split second the first target is destroyed, the turret automatically snaps to the commander's target, ready to fire again. Factor in third-generation thermal sights that can see through smoke and pitch-black darkness, crosswind sensors, barrel temperature monitors, and real-time ballistic computers, and this thing can accurately destroy targets miles away while sprinting at top speed over rough terrain. That capability makes it absolutely lethal on the battlefield. Now, let's address the elephant in the room: survivability. Critics love to call wheeled armor glass cannons, claiming one hit from an RPG turns them into a burning pile of scrap metal. And yes, its base hull is an aluminum alloy and ballistic steel that only stops 14.5mm heavy machine gun armor-piercing rounds. But nobody goes to a modern war completely naked these days. The Centauro II is designed to accept modular add-on armor packages, both passive composite blocks and explosive reactive armor, ERA. Fully kitted out, its frontal arc can easily defeat 30mm armor-piercing rounds from enemy infantry fighting vehicles, keeping the crew safe in a direct firefight. But its true survival philosophy is simple: don't get seen and don't get hit. It's equipped with a highly sensitive laser warning receiver. If an enemy anti-tank team paints the vehicle with a laser targeting system, the Centauro instantly detects it, automatically pops multispectral smoke grenades to completely break the visual and thermal line of sight, and calculates the exact GPS coordinates of whoever is targeting them so the main gun can return fire. Add in a V-shaped hull specifically designed to deflect the upward explosive blast from anti-tank mines and buried IEDs, and crew survivability is actually incredibly high in asymmetrical warfare. You might be wondering, who's actually using this beast? Has it seen combat, or is it just a showroom model? The primary user is the Italian Army, who originally commissioned the project to modernize and replace their aging fleet. But the most interesting case study, and one that sent shockwaves through the global defense procurement world, is the Brazilian Army, who recently signed a massive contract to acquire the Centauro II for their VBC CAV program. Why Brazil? It comes down to pure geography. Brazil is the 5th largest country on Earth, featuring everything from dense jungles to sprawling urban centers and massive highway networks. Moving heavy tracked tanks across a country that size takes weeks and astronomical amounts of money. They needed a vehicle that could drive straight down the interstate highway from one state to another in a matter of hours, and upon arrival, possess the overwhelming firepower to kill an enemy MBT. The Centauro II completely blew its competitors like the Canadian LAV-700 and the Chinese ST-1 out of the water during trials. While the Centauro II is brand new and hasn't seen massive conventional warfare yet, its DNA is heavily combat-proven. Its older brother, the 105mm B-1 Centauro, has been through hell and back, from peacekeeping operations fighting urban militias in the narrow, chaotic streets of Somalia in the 90s to intense high-risk deployments in Iraq and Lebanon. Those deployments proved that in tight urban environments, the rapid response, maneuverability, and ability to quickly scan narrow streets heavily outclasses a bulky tracked tank whose turret might get snagged on buildings. And all that blood-earned real-world experience was directly fed into upgrading the Centauro II's design. To give you guys a concrete look at the value proposition, let's break down the deep specs, estimated costs, and most importantly, the operating cost per hour of the Centauro II. Looking at the specs, a 30-ton combat weight combined with a massive 720 horsepower Iveco diesel engine gives this thing a phenomenal power-to-weight ratio. It can sprint from a dead stop to its top speed of 65 miles per hour incredibly fast, with a staggering operational range of 500 miles on a single tank of gas. This is an absolute nightmare for an enemy's static defense lines, because a platoon of these can flank your positions, encircle your logistics hub, and cut off your retreat before you even know what's happening. In terms of firepower, the 120mm NATO standard smoothbore gun can fire all standard AP-FSDS kinetic rounds to punch through enemy armor, as well as highly lethal programmable airburst munitions, meaning it can effectively neutralize anything from heavily armored vehicles to infantry squads dug deep into trenches. When we look at the acquisition cost of roughly 7.5 to 8.5 million US dollars per unit, it might not sound cheap at first glance, but compare that to a top-tier modern main battle tank, which can easily cost upwards of $15 to $20 million per hull. You're effectively outfitting your military with MBT-level armor-killing firepower for nearly half the upfront price. But the real knockout punch, the metric that has generals and defense accountants drooling, is that last line: operating cost per hour. Taking the Centauro II out for a combat patrol or a multi-day training exercise only costs around $250 to $350 US dollars an hour, and that includes diesel fuel, standard wear and tear on the tires, and routine mechanical maintenance. If you fire up the gas-guzzling turbine on a 60-ton tracked MBT, the massive fuel burn and the sheer excruciating cost of constantly replacing worn-out steel tracks can easily skyrocket your operating costs to well over $1,000 an hour. That is a 3 to 4 times cost difference. This represents a massive return on investment for a nation's defense budget, allowing militaries to train their crews more frequently and aggressively without bleeding their maintenance funds dry. Some of you might be asking, wait, how does this compare to the Japanese Type 16 maneuver combat vehicle? Believe it or not, the Centauro II's unit and operating costs are almost half the price of the Japanese Type 16. That doesn't mean the Japanese vehicle is twice as advanced or twice as lethal. It all comes down to basic economics and economy of scale. Japan only produces a limited run of these vehicles exclusively for their own self-defense forces. Because of export restrictions, they use custom-made engines and bespoke domestically manufactured parts, which makes the manufacturing line and long-term maintenance insanely expensive. Italy, on the other hand, played it incredibly smart. They designed the Centauro II with the global export market in mind and heavily utilized commercial off-the-shelf parts shared with Iveco's commercial heavy truck division. That makes spare parts vastly cheaper, incredibly resilient to supply chain shocks, and much easier to source globally. That is what a truly forward-thinking defense strategy looks like: building high-end weapons you can actually afford to fix when they break. So I think the picture is crystal clear. The Centauro II isn't meant to sit in a trench and trade punches with a heavy MBT like a heavyweight boxer. It's a sniper on wheels, a highly mobile, heavily armed assassin. Its core doctrine is to use its blistering speed to seize advantageous terrain, use its advanced thermal sensors to spot the enemy first, deliver a devastating 120mm kill shot, and immediately displace and relocate before the enemy even knows where the attack came from. In the military world, no single weapon is perfect. It's still a massive, ongoing debate among modern strategists. In an era where cheap suicide drones, loitering munitions, and javelin missiles are everywhere, is a lightly armored but highly mobile wheeled vehicle the actual future of ground warfare? Or is it just an expensive piece of target practice waiting to be hit? What do you guys think? If you're looking at defending a country with a vast, developed highway infrastructure, is a fast-moving system like this the right strategic move? Or are the heavily armored MBTs still absolutely essential to holding the line? Drop your thoughts in the comments below. I'll be reading and I'm ready to debate you guys. If you enjoyed this no BS, forward-thinking deep dive into modern military tech, hit that like button, share it out, and make sure to subscribe to my channel. I'm Mick, and I'll catch you guys in the next video.